All right, so we are given some information about how a soil passes through a stack of sieves for classification. We're given liquid limit of 33%, plasticity index of 12%, told it's an inorganic soil, and then asked to find the soil's group name and group symbol. All right, so if you are watching this, I would highly recommend having the flowcharts and tables and graphs that I'm going to talk about up next to you so you can follow along as this is going, because those are really the tools for how you do these problems. You don't really do them through mathematics, right? So please follow along on there. So for this percent passing in the sieves, right? If you remember from the videos, the way we classify soils is we have these stack of sieves and we essentially shake them up, right? And on the top you have a very coarse sieve, and on the bottom you have a very fine one, right? So, and then what you get reported is what's called the percent passing for that sieve. And so the two most important ones are the number 4, which is all the way at the top, and the number 200, which is all the way at the bottom. And then under the number 200, you have literally what's called a pan. It's just not a sieve, it's just a pan to collect everything to make sure it doesn't drop all over the ground, right? So the way we then break this up is, for classification, we're going to take that information about the sieves and we're going to determine how much of the soil is gravel, how much of the soil is sand, and how much of the soil is what's called fines, right? And your fines are pretty much just anything that is finer or smaller diameter than sand, right? And the way we're going to abbreviate these is we're going to make it GSF, right? And we're going to break it out by percent. So gravel is defined as everything big enough that it doesn't go through the number 4 sieve. So what that means is we look at the percent passing. So 70% of the soil got through the number 4 sieve, right? Now, if 70% of the soil went through it, that means that 30% was trapped above it. And if 30% is trapped above the number 4 sieve, that means 30% is bigger than number 4. Therefore, 30% of the soil is gravel. All right. So the next thing we look at is we look at this 30% passing the number 200 sieve, right? So 30% goes through the number 200 and ends up sitting on the bottom on that pan. So our fines are defined as everything that is smaller than the number 200 sieve. So if 30% gets through the number 200, that means 30% is smaller than sand. 30% is fines. So that gives us what percent is fines. The last thing we need to find out is how much sand there is. So to get the sand, you really kind of do process of elimination, right? If you got 30% gravel and 30% fines, well, whatever's left over has to be sand. So 100% minus 30% minus 30% gives us 40%. So that tells us that 40% of the soil is sand. All right. The next bit of information we're going to need comes from the liquid limit and the plasticity index, right? So if you remember back to the slides, it gives an equation. The plasticity index is equal to the liquid limit, or LL, minus the plastic limit, PL, right? So if the plasticity index is 12%, the liquid limit is 33%, that means that the plastic limit is 21%. And that comes up as useful when we're going through our classification. So now that we have all this information, we can start to actually classify our soil. And the place you start is with the chart that looks like this. So I haven't recreated the entire chart because you should have it pulled up. I'm just giving enough to start walking through classifying the soil, right? So the first thing we're going to look at is our soil a coarse soil or a fine soil? And the way we do that is we look at, is the soil greater than 50% fines or less than 50% fines? If it's greater than 50% fines, that would tell us we had a fine soil. If it's less than 50% fines, that tells us we have a coarse soil. So we have 70% that's not fines, 30 and 40, and we have 30% that is fine. So that tells us that we have a coarse soil. So the next thing we look at is there more gravel or is there more sand? Well, sand is 40% and gravel is 30%, so that tells us we have more sand. All right, our next decision point is it greater than 12% fines or is it a clean sand, aka less than 12% fines? So we have 30% fines. That is a number that is greater than 12. So that puts us to there. And then if you look a little bit further right from the table to see where that takes us to next, it tells you that you have either an SM soil or an SC soil. Well, but then the table doesn't give you anything further on how to classify it. So from there, you have to go to table 3.3. Really, in general, you go to any of table 3.2, 3.3, or 3.4. It just depends on which table your narrowed down classifications are. So SM and SC both happen to be on table 3.3. Right? So if we look at table 3.3, the specifications for SM and SC, so SM says the Atterberg limit is below the A line or the plasticity index is less than 4. For SC, it says that the Atterberg limit is above the A line and the plasticity index is greater than 7. Okay, so we have a plasticity index of 12. That is a number that is greater than 7. So we've met one of the conditions for SC. So now we need to see if we meet the other condition, this Atterberg limit above the A line. So to do this, we have to look at the USCS plasticity chart, which looks something like this. All right, so using the liquid limit and the plasticity index for our soil, we're going to see if that point that it plots is above or below that A line. So if we go to 33% for our liquid limit, and we go to 12% for our plasticity index, and we see where that point is, we see that that point is above the A line, right? So Atterberg limit plots above the A line. So now we can see that we had two conditions that were required to be an SC soil. We have met both of them. Therefore, we know that we have an SC, which is a clayey sand. And that's our classification.